And so in the last two talks, we've seen how important it is to relate metabolomic information to the biologist in essence. The next talk will do the same thing. He will do the next speaker will be Bernd Haas from Biocrates Life Sciences. It's a company in Austria. And he's going to describe how we can take metabolomic information and put it into our networks that many of our biologists are familiar with. So I look forward to your talk.
Thank you for your kind introduction. Well, from my background, I'm a computer scientist with focus on software engineering, and I spend a lot of time in automating all the workflow. Well, you have to know that we are focusing on targeted metabolomics, and we have realized a software with which is the workflow supported from the sample registration to the mapping of the concentrations to the metabolic pathways. Well, we were founded in 2002, and we also provide kits. And what is possible with this combination of software and kits can be seen here in this publication which came out recently in Nature Medicine, where this group was able to find biomarkers to predict Alzheimer. And this was possible because we are addressing some major problems. One of the major problems is that we have different laboratories using different sample preparations. We have different instruments, and this causes a problem that results sometimes are not comparable. And we address this problem that we provide a metabolomics kit with which you can measure more than 180 metabolites and also lipids. And we provide also the software workflow with that. And this kit is validated on all these instruments, and we provide also the sample preparation. So with the software, it is also possible to import concentration data, which comes from other technologies. It's just important that we have a molecule with an absolute concentration. Inside the database, we store the concentration in micromolar, so that makes it possible that you can compare the results across different projects. We have also technical validation, which I will show you later, so that the concentrations are all quality tagged. We have a project import-export feature in the software so that laboratories can move project from one organization to the other, or that they can merge their data together to set up something like a global metabolomics cloud service, for example. Here what you see is the workflow that starts from the LIMS and ends up here at the point where we have validated concentration data. And what you can see here that most of the time is spent on the instrument, because we have a lot of chromatograms which are measured. But as you see, the data processing doesn't need so much time, because we have highly automated this complete process. And also you see, we just use the instrument software, so we give the job files to the instrument software and take the results from them. Let's start with the software. I will guide you now through the software step by step with the user interface. It's designed that we have on the left side the toolbar where you can click and you get into the workflow. The workflow starts from top to the bottom and also from left to right. We have, first of all, a sample registration. You can register samples manually, step by step, or import them from a text file. We fully automate, label them with a barcode, and you can infinitely add groups and variables to the samples. These are later needed for the statistical analysis. Well, with these samples, you then can generate a plate view, and as you see, we also put on the plate our control samples. They have different colors here. We have blank, zero samples, standards, quality controls, and here are the unknowns. And these virtual plates can then be exported, and here you can select the mass spectrometry type. We can create then for the mass spectrometry software specific job file, so that the user doesn't take care of that. And what is going on then, we give the job file to the instrument software, there the run is performed, and we then get back the result files. We convert raw files with the ProteoWizard tool, and with the FIA run, we then identify and quantify and isotope correct the results, and we do the data processing so that we have the absolute concentrations in the database. What is also possible, of course, especially for LC-MS, the quantification is done with multi-quant or analyst or whatever. We can import the complete result files as well. We have also interface to the robot system, so if the sample preparation is done there, the well positions are reported back to the software, which is also helps to automate the process as well. Well, when we get the raw files, please pay attention here on the file names. Here we have, for example, WIF files from maybe SciEx. We have encoded in the WIF file name all information that we need to assign the file in the database, because we need the plate barcode here, for example, sample barcode, or the well position, that we can assign the raw file to the correct position in the database. And what is important to know, that we also store the raw file itself in the database so that it's archived there. Well, you can import them from different instrument types, and also the LC-MS result files we import. And what is also new, what we bring up in the next version, you can import concentration data from any text file, and we are working on it to also support MCONC and MCTAP. So let's come to the next step in the workflow, the technical validation. And what you see here is we have an additional module which we only use Biocrates internally. It's the MET-OP module that's used to set up the operating procedure. Well, there we define the identification and quantification and technical validation parameters which are required later to fully automatically process the plate. So when I click here on this validate button, it fully automatically validates all metabolites of all wells. And here you see all the injections of each well. When you click here on a well, you see the injections. When you click on the injection, you see the results here of this injection. And if there went something wrong on the plate, you see it's labeled yellow. Yeah? So this gets really a fast overview about your analytical quality. And what you can, of course, do is you see immediately where the problem is. We have also the possibility to track quality controls over the time, and also you can check how an analyte behaves across the complete plate on different wells. So to get out the data, we have here the MetStat module. You can create a report context. That's something like a file where you just store your decisions that you take while data analysis. It's just recording all actions you take there. But because we are using in background an Oracle database, we don't have file, we just have such a report context. And you can easily switch just by clicking here between these contexts to get a different report. So in the MetStat module, in the next step, we have here all our already measured samples. And we can access this here in the upper left corner. We can open a filter where you can use endless search features to get out the samples which you want to combine for data analysis. You click here on this button to get it on the right side, which samples you want to analyze. And this makes it possible not just to analyze a complete plate. You can combine, for example, you can take QCs and compare them from different plates, or you can compare different projects. So you have here any flexibility to combine data. And this is possible because we have the data structured inside the database on a sample level. And this is important to know. So this makes the flexibility of the tool. Just by clicking here on the next tab, the selected samples are then, the data of the selected sample is loaded into this user interface. And as you see, we have the sample information here available, as well as the metabolites and the concentration values in micromolar. Of course, we have annotated them. You can just click on the BioID button and select an ID, and then it's shown up which BioID these molecules have. And the colors here represent the validation status, if they are valid or if there is something wrong. What you can do here on this user interface, you can change the unit, so you can export also in different units than micromolar. And it's changing the value on the fly inside the software, and the data in the database is not affected of that. So you have a flexibility here to export data. You can also normalize data just by clicking here on the fly. It normalizes the data on the user interface. Here, you can click on export, and you can export it in several different formats. With this, I can tell you also later, I have more details to that. But actually, this is the workflow that we use to come to our quality control concentration data. So I don't want to end the workflow here. I want to show you also the data analysis aspects of that. We have here in Metabolomics two areas. These are the statistical analysis and the pathway analysis. And as you see, we have also tried to automate this as good as possible so that you can get your first results within 5 minutes, or if you want to play around with the data, you take 2 hours or more. Just by clicking here on the next tab, it directly loads the data from the display tab to the statistical analysis. And here you can start by clicking here a wizard where you select the groups of the linked samples, and then you can select the tests which you want to execute. So we have also multivariate analysis here available, and the most important tests needed for the data analysis. So when we click on finish here in this table, the p-values are added for these tests, and then you can select here the metabolites, and while selecting the metabolites, you get here the box plots. You can then export the data here into a PDF as a statistical report, and all the information which is here in the user interface then is in a PDF file. So now let's come to the pathway analysis. We can take over the data from the statistical analysis. When we click here on this button, then it links the metabolite from the mass spec project to, in this case, we have used human psych, and you can select also the data set here. We support also CAC. We have in background a bio warehouse database where you can load different data sets into this database. And as you see, we also take over the p-values here to this user interface. Yeah? So you can select here the statistical relevant metabolites, and then all pathways are shown up here where this metabolite is part of. And when you select then the pathway, then you see here the up and down regulated metabolites. So the green one are the up-regulated and the red one are the down-regulated. You have here also a different view that you have a list of metabolites. When you click here, it selects the metabolite, and you see also here the enzyme reactions. You can switch between layouts. Please note that this is not a static image what we generate here. It's really a live rendered graph which you can move and which you can change and which you can hide nodes and which you can export to images, and you can also hide the structures so that you only see the names to get a better overview. There are a lot of manipulation possibilities. The next is you can also pick out two metabolites and find all routes between these two metabolites. Or you can pick out a metabolite and get the complete neighborhood of the linked metabolites, which are linked via enzyme reaction to this one. And of course, we have a search feature which makes it possible to look up by name, and you can look up, for example, any molecule in the data set and display this pathway or whatever. So you have seen now the complete workflow to the pathway analysis, but what I want to tell you is, I mean, that's not the only way to analyze data. There exists a lot of fantastic tools out there, and there exists a lot of fantastic methods to analyze the data. What we want to do is that we offer as much as possible tool-specific export formats. So we have, for example, now integrated MetaboAnalyst text files. I mean, you can say, okay, it's just a text file, but be honestly, it is really a problem because everyone is always moving around text tables, data on text tables, and this takes so much time, and I think that's error-prone, and that should be done by software. And what we also have is an XML export file, and we have an R package with which you can then load the data from the XML file directly to R without need any parser then again. And what tool you ever need or want to use, you get out there your plots and your tables data, which you then combine in a report. Well, some of you are also software developers. I want to also give you 2 slides and insight how we work at Biocrates. So this is designed in Java. The complete application, we are using Eclipse. And what really worked well was for requirements engineering, Bacilla in combination with Mylin and Subversion version control system. And well, some experiences we made while development. When I started in the company, I really had no clue what we are doing, but I was learning and learning. So I started with a user interface, and I got feedback from the lab and from the users. This is bullshit. And then I said, okay, I will correct this. And we had a lot of innovation cycles. And so the people in the lab learned from the software developers and vice versa. So rapid prototyping was really the approach to choose. Yeah? And we did also continuous code refactoring. And what was really an important issue that we don't should mix up concentration data inside the database, because this will create problems in the software design. Yeah. What's also excellent for the software quality, fatal error reporting. The software, whenever you think this will not happen in your software, be sure it will happen, because the software sometimes is complex, and so we pop up every error where the software comes to a situation which is not for which the software should not happen. Well, what you have seen now is an overview of the complete workflow and software, what we offer in combination with our kit. And as you see, we have tried to radically simplify it and to make metabolomics as usable and easy as possible for the science community, so that we have more time to do rocket science. If you have interest to see the software in live, then you can come to our booth. Thank you.
Thank you very much. Thank you very much, Bernd. One thing that I really like, as mass spectrometrists are starting to be able to collect thousands of data sets in a day,
yes,
you have a very nice organization workflow. And that was, we hadn't covered that in the rest of the speakers. And I think this is very key, because I know as a graduate student or a postdoc who sits in the laboratory, it's really easy to transpose one item of a data set and you have completely incorrect interpretation. So it's really wonderful. Are there any questions?
Actually, right along those points, we like your software, we use your products. They perform quite well. One of the things that I would like to see in the software in the end is the ability to store workflows and results of those workflows, so that you've taken a number of samples, you've run it through a statistical processing pipeline, you've done an analysis. It actually is, there's no way to essentially store. You can store the result from that workflow, but you can't actually capture that entire workflow that I'm aware right now. Yeah,
this is what we now address with this feature, what I show you here. Actually, this is what we want to do. I don't know, have you used this feature? It's the report.
Apparently not.
Okay, so maybe it's just a matter.
I should talk offline about the program. So it's basically, I think he's asking about, can you store every job that you've done, so that in the past you don't have to go back to it?
Yeah, actually.
That's what that feature is.
That's it, yeah. It records it. And what you can also do, you can share this report then. So you can, first it's private, and then you can set it global, and everyone who is connected to the database can see it then later. So that's the idea here. And you can copy one.
All right, awesome, thanks.
You're welcome.
Sounds great. Let's thank Bernd for a wonderful lecture. And,
thank you.